everybody, and welcome to my tutorial on not the binary light. This one's a doozy. So this module is identified by a light here, which you're able to tap and swap it between being black and being unlit, or like grayish white, whatever the default state. Your goal is to get to the goal number starting from 1 with only the operations times 2 and minus 1. The only limitations in the module are that you cannot go either below 1 or greater than 1 above the goal. So you want to try to either have your times 2, your last times 2 get you to the goal, or your last times 2 get you 1 above the goal that you can subtract 1 and get down to it. So in this case, your goal number is just a concatenation of the digits of the serial number. So we have an 8 and a 0, so putting them together, it's just 80. 80. So we have to get to 80 starting from 1. So I suggest you pull up Text Field Calculator, the version 2, which can be found on the repo, because we're going to write out a system of equations, a system of operations to determine the fastest way to get to the goal number. So to find the fastest way to get to the goal number, it's actually pretty simple. If your number is even, you divide it by 2. If your number is odd, say 5, you add 1. That's just not the right number. And you keep doing that until you get down to 1. And now that we're down to 1, we now know the fastest way to get to the goal number. Turn every division operation into a times 2, and every plus operation into a minus 1. So in order, we have times 2, minus 1, times 2, minus 1, times 2, times 2, times 2, times 2. Now, times 2 corresponds to holding the light when it's black, and minus 1 corresponds to holding it when it's white or unlit. But after every press, these can change. Now, to calculate when it's going to change, you want to take every one of these equations besides the first one, put it in parentheses, and we're going to square them. So let's just put them all in parentheses first. And yes, even the top one. And we are going to square all of these. Now, from these squared values, the unlit and black will swap what they do, similar to like left and right, or yes and no if you know those modules. They will swap what they do if the middle digit is odd, or in the case of even digits, or an even amount of digits, the middle right. So the one directly right of what would be the dead center. So yeah, so starting from the first operation, let's just put what the middle digit is from each of these squared operations. So in this case, this times 2 would be even, because 4 is the middle digit, 4 is even. Middle digit here is 6, that's even. Middle digit here is 9, so it's odd. Then we got even for 36, and then 25 is odd. And then 100 is even, and then 400 is even, and then 1600 is even. And we don't care about the last one. That's never going to change. Now, if above the... Okay, so once you perform the operation, if the letter above it is O, you swap them. Otherwise, you don't swap the functions. So let's just start inputting. So we have a times 2 here. So we input on black. If it flashes green, that means that the input was valid. It doesn't necessarily mean it was correct or the fastest way. It just means it was a valid input. If it's red and strikes you, it was an invalid input and you went out of the range. At that point, the module would completely reset. Back to 1, I believe. So after that times 2, our number was even, so we don't swap, so we input another times 2. It was even again, so we don't swap. Now we inputted -1. Now that landed us on an odd number. So now the function switched. So now times 2 is white and -1 is black. So we need to input another times 2, so we're going to do it on white now. That's even, so we don't swap them. Then we do -1, which in this case is now black. Input that, that's fine. Odd means we swap them again. So now they're back to their original functions, which means we can do a times 2 here. It's even, so we don't swap, times 2. Even, so we don't swap, times 2. Even, so we don't swap, and the final times 2. We'll solve the module. Yeah, once you get to the gold number, it immediately solves the mod. This module is pretty variable. It kind of depends on what your serial number was. As you saw the case before this, let me just go back a lot. You can have cases like this, where I had 7010 as my previous. But let's do another one just for clarity. So we have another, not the binary light. And in this case, our gold number is 84. So we will do the same steps. 84 is even, so divide by 2. 42 is even, so divide by 2. 21 is odd, so add 1. 22 over 2, 11 plus 1. 12 over 2, 6 over 2, 3 plus 1, 4 over 2, and 2 over 2. Let's get these all in parentheses. Bam, bam, bam. And let's get them all squared. And write down our list of operations. In this case, we have a divide, so times 2, divide, so times 2, plus 1, so -1, times 2, times 2, -1, times 2, -1, times 2, and times 2. Starting from the first one, always start from the first squared operation. This one never matters, because after you input the first, it gives you the number of it leads to the number on the second. The number of the first squared operation. So we got even here, 16, even right digit. We have an odd for 9. We have an even for 36, because the middle right digit is even. The direct middle of 144 is 4, which is even. 121 is 2, that's even. 484 is 8, that's even. 441 is 4, that's even. And 1764 would be 6, that's also even. And then we disregard the last one. Because there will never be a press after, there will never be aftermath of the last press, because it'll solve the mod, hopefully. So, okay, let's start inputting. So times 2. Remember, it starts with black times 2 and white -1. So black times 2, it's even, so we don't change. Black times 2, it's even, so we don't change. White -1, it's odd, so we do change. So now white is times 2 and black is -1. So times 2, even, so we don't change. Times 2, even, so we don't change. -1. Even, so we don't change, times 2. Even, so we don't change. You get the idea. -1, even, times 2, even, times 2. Solves the module. And that's not the binary light. I'm not really sure how it relates to regular the binary light. I didn't make the tutorial on that. I'll have to learn that module after this. But yeah, that's not the binary light. Have a good day, and thank you for watching.